Swayam Prabha. Digital India. Educated India.
Hello everyone. In this lecture we will discuss about design for net zero energy building, lighting, ventilation, views and human comfort in an overall sense. So if you see this illustration, this will talk about what are the ways in which we can generate electricity, generate power on any given site. So here we have some options. You can see like a solar photovoltaic cells, we have windmills, you know we have like other like a geothermal ways, other we have like a hydel actually harvesting ways to harvest energy from the tidal waves, etc. So and we have like a biomass over here, so there are several ways in which the electricity can be actually harvested on any given site, compared to a centralized actually power generation unit. For example, you can see here in this background, this is like a thermal power plant, so it's a bigger it's big in capacity, and similarly on the same scale it will have a immense like a huge amount of like a waste generation, emissions, and creating like a byproducts, so all of those things. So how this can be actually taken care of, using like a natural means, using like a these the energy systems which are available plenty for our like utilization, so how we can minimize, how we can actually maximize uses of such actually energy sources on our given site, and we can go actually independent of the grid. So that is actually whole actually thing we are discussing about over here. So the integration of actually these renewable energy sources in our like projects is actually a matter of integration from the like inception of the project. These things can be installed or retrofitted also later on, but it is better that if we integrate them since the conception of the project, because it will actually help us in like a planning the facility in such a way so that we can minimize the energy consumption also. We can actually create a parallel actually electricity distribution system also if there is any need, so we can keep actually provisions to handle renewable energy sources on our like a site. Well, solar energy is like a ubiquitous thing. We can harvest solar energy at most of the places, but other actually energy sources are place based, like a place specific. So it depends like what kind of facility, what kind of geography or climate we have. For example, biogas, for biogas, this can also be actually utilized at most of the places, but these windmills and hydel electricity, geothermal energies, energy. So these actually three things are place specific, climate and geography and topography specific. So we have to be actually cautious in like a site selection also, what kind of site we are given, and accordingly which renewable energy source is suitable for our location. Further in this, provision for like a combined actually approach of like energy supply should also be made. For example, if we have like a surplus energy to supply to the grid, so how that can be actually distributed back to the system, so those provisions should also be there in case like as if there is some emergent situation and we need to draw actually electricity from the grid, then we have that provision also. So moving on in this, like how a solar photovoltaic actually cells and these actually panels works. You can see this is the unit actually solar cell, okay, here on the top. Okay, then a number of like these solar cells form this solar module, and a number of these modules actually form a solar panel, and then a panel, several actually units of panels together, they form this actually solar array. So you see like this is how it is like increasing in its scale. And well, there are other like components also for this solar voltaic actually photoelectricity based actually power generation. We need require electricity meter, AC isolator, we need fuse box, inverter, battery, charge controller, generation meter, DC isolator, cabling, mounting, tracking system, etc. So with the help of all of these components, one can easily actually install these units on our like projects. Well, government of India through its like a Ministry of Renewable Energy Resources, they have actually this provision to facilitate a subsidized and a easy installation of like a solar photovoltaic cells in the individual households also. So one can actually avail these facility by visiting their website, and they are or maybe contacting the local actually contact person. Further, so solar energy deployment, how it takes place. So I'll quickly introduce this detail to you. Like based on the availability of space and capital, solar energy can either be generated off-site at utility level or on-site at small scale. Both types of generation mechanisms are guided by their own rules and policy frameworks. The first one, utility-driven solar project development. In this, these are large scale centralized solar power plants which generate electricity to be sold to power utilities. These plants require large tracts of land and considerable capital. These plants actually have a long term power purchase agreement with the power utility and usually serve to fulfill their renewable purchase obligations. Second, customer driven solar project development. So these are small scale decentralized solar power plants installed by electricity consumers in their own premises like households, etc., or maybe individual projects such as maybe an institutional campus or something. These types of projects require less area and lesser capital investment compared to the previous one. These systems are further divided into two parts. The first one, grid connected systems. Grid connected PV systems are designed to work in conjunction with the utility grid. As I said, if we have like a surplus electricity to sell to the grid, or in case like if there is some emergency situation and we need to buy electricity, for example, if our own like a site based actually production is lesser than the consumption, then we will be forced to actually buy. Such systems can either supply the complete generated electricity to the grid or can use the electricity for building use and supply over the excess power to the grid. Second, standalone systems. So standalone PV systems are designed to operate within the context of the building and are not connected to the grid. The electricity generated is consumed by the building, and excess energy generated can be stored in the batteries for like a future use. So these are the actually structures you understood, these are the actually standard formats of like a solar energy power generation and its deployment. Further, solar energy electricity generation system. So a complete solar electricity generation system consists of components to produce electricity, convert generated DC into AC that can be used by equipment installed in the building, and store excess generated electricity for those systems which do not intend to sell excess generated electricity to the grid. So what are these actually mediums? Solar photovoltaic cells, panels. Solar panels are the basic part of a solar electricity generation system. These panels consist of numerous solar cells which are made up of semiconducting material. These solar cells are responsible for conversion of incident light into usable electricity. Although the size may vary according to generation capacity, location and budget. The typical length of the solar panel ranges between 65 inches and 77 inches, and the breadth ranges from 35 inches to 39 inches. The typical depth of solar panel ranges from 1.4 inches to 1.8 inches. The next component is inverter. The inverter converts the DC produced by the solar panel into AC that can be fed into the grid or used for the operation of electrical appliances. Additionally, the inverter acts as a safety valve between PV system and the electricity mains. You may have seen actually inverters. These small scale inverters are also installed in our like households these days. The next one is like storage batteries, power storing batteries. The storage batteries are used to store excess electric energy generated by the PV system for future use. The batteries are typically employed in PV systems which do not intend to sell excess electricity to the power utilities. The next one, electricity meter. Well, the meter counts the number of units of electricity generated by the PV system. They are essential for calculating the proceeds from the sale of electricity to the grid. Well, for various purposes, we need the electricity like a meter. First, to like understand how much power generation is has happened. Secondly, like how much of like a utility, how much like a electricity is used on the premises. And thirdly, like how much is going out, or if in case we are like a buying in, then how much we are buying in. Further, there are some factors affecting generation of electricity. We will go one by one. Solar cell efficiency is the ratio of electrical output to the incident solar energy. Major factors, efficiency of solar cells are, first one, location, tilt, and orientation. The incident solar radiation varies, significantly with longitude and orientation. Within a particular longitude and orientation, maximum solar radiation is available in a particular tilt angle based on sun path. Well, our Earth is actually a kind of like a sphere, and sun keeps actually moving and keeps changing its path like over the year. So from like a line of Cancer to the line of Capricorn, it keeps moving, every day it changes its orientation, a little bit. So depending upon the actually time of the day and year of the day, the sun's actually the intensity of sun's rays which are falling on a given actually particular place, they actually change. So by changing the orientation of the solar panels towards like the sun, we can actually maximize the receiving actually capacity. Second, overshading. Site characteristics like geography, neighboring buildings, self-shading, cloud factors, they also affect the useful solar radiation falling on the PV panels. System design should be done to minimize panel area affected by the shading. Well, there should not be any obstruction in between, of course, the PV like a panels and the sun, because they will affect the overall like the receipt of the solar radiation, the solar light on the like panels. So, next we have this temperature. So an increase in panel temperature due to solar radiation can affect the PV module performance, especially in crystalline silicon modules. Well, it is estimated that for every 1 degree centigrade increase in ambient temperature above 25 degrees centigrade, the PV module performance decreases in the range of 0.4 to 0.5%. Special considerations are given to design airflow over the backs of the PV modules to avoid higher temperature by excessive heat gains. So we see like the higher the temperature in the atmosphere goes, there will be actually certain amount of decrease in the overall like receipt of that actually like a energy and the power actually generation. So we must actually take care of like this excessive heat to not to allow this excessive heat to actually heat up the PV panels. Finally, we have like a panel efficiency. So panel efficiency is an estimate of successful conversion of incident solar radiation to electric energy. Panel efficiency depends on PV module technology, manufacturing technique, and system design. A crystalline silicon-based module has an efficiency in the range of 12 to 14%, whereas a thin film-based module has an efficiency in the range of 10 to 11%. So, depending upon the brand, make, capacity, and the capital amount required for like an investment, we can actually go for like this deciding actually factor. Next, if you see in the like a windmill, a typical windmill like a energy system has like these many like a components. So you can see from here the first one, the windmill itself. So it has this tower and it has its like a rotors over here, typically like a 3 rotors per like a windmill, and these are actually nestled here with the this power generating actually unit, at its central axis over here. So it has a gearbox, control, rotor shaft, etc., and it generates actually, this is the unit which generates the electricity. And from here this electricity, through the like help of the cables, it goes to the either like a battery bank, it goes to like a DC to AC conversion, then it goes for like a, for example, on-site uses, or maybe supplying to the grid. So this is actually a typical layout of a windmill based energy generation system. So here you see like electricity generated by the turbine can be stored in batteries till it is used locally on site or transferred to the transmission like a grid, so that it can go to the national grid or a state grid, and can it be sold to like external agencies. Typical like this the units of the wind turbines, if you see, like, they have a certain actually architecture, certain like a the design of their structures is like varies like depending upon their usage capacity, etc. So these are the actually typical like a two actually structures, the vertical axis based and a horizontal axis based. So this is like horizontal axis based, the conventional one which we have seen, so we have seen them in a like a huge scale, very big. So these have a horizontal axis wind turbine, they are called as like a HAWT, and these are like examples of like a vertical axis wind turbines called as like a VAWT. So you see this is how they are like their components, they are actually these rotors are actually designed in such a way and arranged in such a way. So these are actually suitable for like a small scale actually power generation units, such as like household or maybe institutional. But these ones are the bigger scale commercial ones, which are huge in scale, and they are installed for like a big scale, like a wind mill energy generation actually systems. Further, coming down to biomass energy generation system. So this is a typical actually illustration how this biomass energy generation system works. So first and foremost, we actually collect the organic material. That organic material can include like a animal waste, like cow dung, etc. Then agricultural waste, the leaves and other like leftovers. And then municipal waste also comes into this, human waste also, like excreta, kitchen waste like vegetables, fruits, choppings, etc. So these actually collectively they can be actually they can constitute this biomass like a resource, organic material, and these are actually they are thrown into this like a biogas digester over here. And this is actually a sealed chamber where this actually it starts actually emitting this biogas. Okay. And then this biogas is actually taken for like a various types of like usages. For example, biogas for like electricity generation, biogas for actually like heating the water, for like a domestic uses, even biogas for like a cooking. So you may have seen actually this facility being used in like Indian villages for a very long period of time, because in Indian villages earlier there used to be a number of like a cattle, every household, almost like every household used to have a certain number of like a cattle. So this actually mechanism of biogas was promoted for a very long period of time, several years ago, several decades ago. And I myself have seen like several such examples in my village and my other like neighboring villages. So where these cooking systems, these like gas stoves were actually fueled by this biogas actually facility. And the sludge part of it goes for like a becoming like a manure, and it can be further actually thrown into the agricultural fields, for it becomes like a natural fertilizer. Okay. So from here actually, if it is like a produced as like a electricity, well, there are several possible uses it can go to, depending upon the volume of the electricity which is generated, the amount of electricity generated. It can serve to a household, maybe a micro neighborhood or a neighborhood, so this is how it typically works. So this is actually an illustration. Some examples from here on, I would like to show the net zero energy buildings, which are actually existing right now in India. So there are several, but I have chosen a few examples to give some idea to you. Like you can maybe look for your like your own city, or maybe a city in your like in your like a nearby city where this kind of like actually projects are existing. You can go for like a detailed case study for your understanding how this project is executed, how it was designed, how it was constructed, and how it is performing in this like a operation stage. So this will give you like a deeper insights about the designing actually net zero energy building. So the first one here, this example taken is like of Infosys building. This is in like a Pocharam, it's a locality in like the city of like Hyderabad. So the location Hyderabad, and it's like an office building. It was newly constructed. A climate where it is situated is hot and dry, and the project area you see over like a 27,000 square meters, and this is connected to the grid, and the EPI, if you see over here, 75 actually a kilowatt hours, per square meter per year. Is actually you see this range over here of this actually power generation on this particular actually this project. So next we have this IGBC building, Indian Green Business Center. This is also located in the city of Hyderabad, and this is also like an office actually project. Well, this was earlier like an existing building. When it was converted into a like a net zero energy building lately, well, climate is same, hot and dry, and then the EPI over here is 80 kilowatt hours per square meter per year. So you see like here this is a little more than the previous one, this Infosys center. So these both of these projects are situated in the city of Hyderabad. Further, we have the first actually net zero energy building example. This is like a Indira Paryavaran Bhavan. This earlier this building used to belong to like Ministry of Environment and Forest, in the like a Lodi colony area, and this is in the city of like a New Delhi. So well, primarily this building is like an office building. Even now it is being used as an office building, and the EPI over here is 44 kilowatt hour per square meter per year. So this is actually a range, and it has see the solar photovoltaic system. So it has given 930 kilowatt actually capacity. So you see over here this overhang on the roofing. So this overhang is actually the structure which supports the solar photovoltaic actually solar panels on top of this building. So almost all of this actually the top of this building, excluding this little cutout which allows actually sun and light to pass in the middle of this building. So except that cut, rest of this actually surface, the top surface of this building is covered in the like photovoltaic solar cells, okay, for its own like a power, to meeting its own like a power needs on the daily basis. So on this project, if you see, the total surface area is around 6,000 square meters, and the total area of panels actually installed on this site is like a quite huge 4,650 square meters, which is over like 75% of the total surface area of this projects. So which is huge if we, in terms of like a ratio, if we see, and total number of panels like 2,844 installed, and the annual energy generation is like a 14.3 lakh units, which is like a quite sufficient. So this actually building takes care of its own like a power requirements, as well as it supplies electricity to the grid. Second, in this slide we have SEPT Research Laboratory from Ahmedabad, Gujarat. This is actually an office and educational actually purpose building. It was actually new construction, climate hot and dry. Project area 498 square meters, and also this has the EPI of 58 kilowatt hour per square meter per year. So in this, if you see like renewable energy integration, 50% of roof covered with 27 kW PV panels tilted at 23-degree facing south on the site, generation equivalent to 770 kilowatt hour per square meter per year. So this is the actually range in it works. Next we have two more examples. This is like a human scapes. This is from Orville, Tamil Nadu. So this is actually community housing project. It's a new type of construction. It is located in a warm and humid actually climatic actually a setting, and the project area 1,680 square meters, and this is connected with the grid also. Next we have actually this example of like a household, a small scale actually project, RNA multi-purpose office come residence. So this is located in like a Sri Lanka, okay, and this is office come actually residence building, and it was like earlier actually an existing building, and this was actually done as a like a retrofitting. This is situated in a tropical climate, 312 square meter, and this is also connected with the grid. So this is an example of like how a small household and house unit can also go for actually such power generation actually things. So this slide actually talks about the world GBC. So the definition of world GBC is a net zero carbon building is highly efficient, highly energy efficient, with all remaining energy from on-site or off-site renewable sources. So the target of this is like, if you see like utilizing like these four methods, how this can be actually implementing in the like a building sector. So by government engagement, by training and education, by corporate engagement, and by certification programs. So the target for like a year 2030 is to that all new buildings must operate at net zero carbon, and by 2050 the target is to go for like 100% of the buildings must operate at net zero carbon. So this is actually kind of a very promising actually target kept for the year like a 2050, where all buildings must actually go for like a becoming a net zero energy building projects. And the key principles actually derived from here, like measure and disclose carbon. So the carbon is the ultimate metric to track and buildings must achieve an annual operational net zero carbon emission balance based on the meter data. Second, reduce energy demand. Prioritize energy efficiency to ensure that buildings are performing as efficiently as possible and not wasting energy. Thirdly, generate balance from like a renewables. Supply remaining demand from renewable energy sources, preferably on-site followed by off-site or from offsets. Lastly, fourth, improve verification and rigor. Over time, progress to include embodied carbon and other impact areas such as zero water and zero waste. So, not just zero like a net zero energy building, but zero water and zero waste building also. So, this is actually a target taken by this World Green Building Council (WGBC). So this is actually quite promising and. This is actually the approach or the strategy which will enable us to achieve actually sustainability target, which we have discussed in the previous lectures. So individually in our own capacity we must actually work to strive for this goal. This slide talks about this the calculation of like a light, the incident light in any like a given space. So you see with the simulation actually through this software, at the two times of the day. This is from like a second floor. It's actually example actually I have taken. So you see at the 9 a.m. and the 3 level how the actually the lux level actually is changing. This is the actually a chart given over here, the illuminance value of lighting analysis. So ranging from 10 to 6000 actually lux. So you see with this color coding how these windows are enabling this particular actually this set of like rooms in the morning hours to get like a sufficient light, and in the evening hours like this actually site. So why is this kind of simulation and analysis is important? Because to actually understand how our building, how our design is going to behave once it is executed. So one we can actually understand, we can have actually a real time actually look of this like how it's going to perform through the help of these simulation methods. So we can take help of like a such simulation like a softwares. Some of them are like a open source and freely available over the internet for like a our like a uses. So I would suggest you look for it, you google for it, you go for some like a open source free software, you install in your computer. It hardly takes like a few MBs, and you conduct your studies. You will have like a better understanding how to perform actually daylighting analysis for your like projects, and accordingly you can actually change your design, or you can improve your design, so the overall actually productivity, overall actually natural light consumption can go higher. Resultantly we can actually depend lesser on the like electricity based requirements. So the criteria which have been discussing like several times, like we must actually reduce our dependence on the like generated electricity. Rather we should actually consume more and more of like a natural lightings in our building premises. Further, I have taken some examples over here for your understanding. So this one actually talks about the biosales. Why biosales are actually the man-made trenches, linear trenches, which runs for like a longer distances. They can actually, help us increasing the recharge of rainwater to the like a ground. So you see in this illustration, how these actually biosales are created along the this actually paved actually movement place, this road, so that all the rainwater which falls on this actually surface can get accumulated in this actually bioswale, and this will help actually recharging in the like a ground. So these are some means which we can adopt on our sites for like a increasing like the recharge of the groundwater, improvement of the like the particulate matter in the air. So by planting a number of like vegetation, how we can improve the air quality in the like a vicinity, in the like a surrounding area. So these are actually small details actually with which overall actually ambience or the atmosphere of any place can be improved over the time. Now we will discuss about some other forms of like a pollution and some like a human comforts. So lighting is one of the actually less talked about pollution. And the excess of like this lighting, how it becomes like a requirement, then it turns into like a polluting actually element. So you see actually this illustration, so this talks about like a lighting which we generally use in the night time, how it becomes a polluting actually thing for the nocturnal life, like other like wildlife forms and other like birds, so they get actually a disturbance in their like a their sleeping pattern, or their like their the like in their own like a normal like activities, they feel actually disturbed. So and then the excess light actually obscures the night sky also, right? So in the like cities which we actually observe these days, we observe actually a halo kind of actually formation of this light. It becomes even more intense with the presence of the dust particles and the suspended particles in the air, so the overall effect actually multiplies, and the overall light actually remains for like a longer period of time, almost the whole night, obscuring actually view to the like a clear sky, and these days no more like stars are visible from the like skies in the like cities. So that's actually one of the actually after effects of this light pollution. Secondly, rather than assisting these plants also feel like a disturbance, because they are all along with these birds and other like a nocturnal like animals. These plants also have their this the daily cycle when they actually go for the like a rest, and you may have heard plants also actually excrete this CO2 in the night time. So this actually spillage of light in excess in the night time disturbs their cycle also, so and then again spilling of the light in the like neighboring properties, so creating like unnecessary actually lighting actually condition for the like neighbors. So there are actually multiple ways you can understand this phenomena, so that overall in an overall sense this actually hinders with the human comfort, the comfort and the condition required for the like other life forms. So we must actually take care of lighting design in our projects, so that it doesn't becomes like a polluting thing for the like others. Next, in this thing, we can focus on like a site water conservation management and quality enhancements. So the how the actually the surface which we usually like a pave, and how we can actually plan to pave in such a way so that the water also keeps penetrating inside the actually top layer of the surface. It doesn't completely goes as like a runoff, because runoff water goes to the like a to the rivers and eventually to the like oceans, depriving actually the chance of getting this water in the like a top surface. So this actually this pavement design also should be taken care of properly, allowing actually this water actually penetration in the like ground. So you can see in these illustrations, so here with the like a 25% of shallow infiltration, and 40% goes in the like a transpiration through the like the plants and the overall like the surface. 10% water goes as a, like a runoff in this actually condition when there is a huge vegetation, ample amount of vegetation is there. It's a, like a natural ground cover. And the second one, there is like a 10 to 20% impervious surface. So here only 21% goes for like a shallow infiltration, 20% goes for like a runoff, 21% goes is as like a deep infiltration. Further, in this illustration, if you see the overall, it has like a 35 to 50% of impervious surface on the like a ground level. So it increases actually this runoff. Runoff has increased to like a 30%, and this a shallow and a deep infiltration are respectively 20 and 15% only. Whereas in this case, this last one 70, where there is a actually this impervious surface to the amount of like 75 to 100%, the runoff water is more than 50% at 55%, and this the deeper penetration and shallow penetration is only like a 10 and 5%, which is actually a worrisome situation, which causes actually a scarcity of water in the like a top soil level. So we must actually take care of these situations for like a pervious actually site actually design, where the top surface is actually taken care of. Further in this Next illustration, if you see the here it is shown for like optimizing the window sizing for like a daylighting. So the how this can be actually taken care of. So in this scale, if you see in this illustration here, first figure, 10% window to wall ratio WWR. Here it is 20% window to wall ratio 20. So in these actually both of these situations, you can see like how the it drives the net saving. Here on this actually x-axis, this is window to wall ratio 5, 10, 15 and 20%. So the daylighting, like how much of energy saving goes, and window thermal losses. So both are actually, all of these three things are actually plotted over here on the scale of this energy savings or energy losses. So on the saving part, if you see, more than like when we are going for like a 10%, there is a like a usual actually saving over here. If we are going for like a lesser than that, then this actually in this area, the daylighting saving and the net saving is relatively like a much lower. So actually we can plan this WWR ratios to increase the daylight actually efficiency in our buildings. Further, through like how much the losses through the like a window. So the window energy use over here on this y scale, percentage of like a heating loss, and on this scale we have this WWR ratio from 0 to 80%. So you see with this illustration you can understand how much like the WWR is actually talking about. So here the window panes are huge, the number of actually panes are more, and the sizes are actually larger relatively. In this one, the window openings are much smaller. So like from the like a window energy usage, if you see, from 15% to 43%, this is how it's increasing. So more the actually opening area, more actually this actually heating loss, at this range. So this is quite evident from here. So WWR is a very important actually factor to be considered in the like a design. So you can take help of these daylighting software which I suggested earlier, for the simulation of your designs, and you can rectify before the project goes for like a construction. And in this one, like a comfort issues related with the windows are explained over here. So you see like there are several like a phenomena at the same time. Like a body, you may be aware of, our body keeps radiating actually energy, heat, from our bodies. So this is here. And windows actually, depending upon the climate and weather outside, either they receive or they lose actually the heat energy from inside. And temperature stratification from here, like a 16 degrees centigrade to 21 degrees centigrade. So the cold convective actually currents, they go down, you may be aware of, and the hot actually convective currents, they go in the like a top level. Okay, and then from the ventilators they actually go out. So this is how actually the ventilation, natural ventilation, this convection actually system works inside like a confined space. Here in this actually slide, I have taken reflectance value of like a different like a finishes. So you can see in the paints, what is the like a reflectance value. So if it is like highly reflective white, it reflects up to like a 90%. If it is like a dark brown, only like 12%. In between we have all of these like a shades, and the colors. You can understand from here how much is the like a respective reflectance of these paint materials. Further we have wood. So in the wood, like from cherry to maple, and this range you can understand from 20 to 54% of reflectance. Similarly, we have the different other materials also, such as like carpets, linoleum, concrete, walls, furnishings, and ceiling tiles. So you can see these high reflective tiles which are installed on the like the roofing systems to minimize the heat load on the like a top floors. It comes in a range of like a 90% of reflectance, which is quite considerable. So this actually table helps us understand what kind of finishing materials we should use in our buildings, and the components of the building, depending upon the location of that project, in like any given climate, topographical level, or like in this weather conditions. So depending upon the like time of the year, we can actually choose like a such finishing materials for our like building premises. Further, for the inside like ceiling reflectance strategies, so we can similarly choose the carpet materials, the wall finishes, the ceiling finishes, etc. The other like materials like using like a reflective ceiling tiles. Here if we want to propagate like a more light in a like a diffused manner, we can use like a reflective paints on the ceilings. We can go for like a paint ductwork and pipe with reflective color, so the ducts and pipes which pass inside actually the interior spaces which are clearly visible from like beneath, we can paint them also. You may have seen some like restaurants or maybe theaters where the public areas, in the public areas, they keep all of these ducts and pipes like exposed, and they color it in a, like a dark black. But some places, depending upon the application and the usage, if it is like a factory, so sometimes they actually color it in like a white to actually create this reflection, so that there is a actually ample light, diffused light everywhere, so that one can actually see what is going on. So it depends on the like application and the uses. Accordingly we can choose the like a surface materials and other things. Okay, on this range, actually, this floor reflectance strategies, because lighting is usually designed for a default floor reflectance of 20%. The floor offers a greater opportunity for improving its reflectance value than either the ceiling or walls. So you see, like this dark carpets like reflectance is almost like close to like 0%, between this 0% to 5%. And then we have these polished concrete with the reflective coating, so this has the reflectance value of 70 to 90%. So in between we have like this white linoleum, light wood, medium wood, typical concrete, typical linoleum, and light carpet. So in these like also we can go for choosing this flooring material, because flooring is the one component which reflects the lights to the like a fullest, because most of the electrical lights are also installed in the ceiling, and they actually throw light to the floor, and then that lights either will be get absorbed or will be reflected by like a certain extent. So we can choose this flooring material with a conscious like approach, how much of like a reflectance, how much of like a diffuse lighting we want inside any given space. So similarly, like in this we are talking about for the lighting. So how these coves, and these fixtures can be actually planned for creating the ample, and the desired lighting levels inside any given space. So you understand from here, consider using not only more efficient lamps, so the compared to like this surface area, actually this has the wider surface area, and this reflects actually light in a more diffused manner. So we cannot actually see the tungsten actually filament here in this actually system of this CFL light. So this works as like a more diffused light source. Further, we have like such arrangements in the like ceiling. You see this cross section over here, it's a cove actually recessed down lighter actually is put up, installed over here, which gives its light, it throws its light in a like a given direction only, in a like a given area only. It doesn't, it spills much light to the like other neighboring areas. So such actually strategies, and compared to this, if we see go for like these fluorescent tube lights, so they actually scatter light to a wider actually surface area. So depending upon the space and application, we can go for choosing the these luminaires also here. So this is actually a relative chart, kept here on this table for your understanding, which shows like the approximate luminous efficacies of these many actually luminaires. So from zero candle to you can see it up to like 100. So it starts from like a candle, from here. So it goes to like a incandescent bulb, then we have like this CFL bulb, then we have this fluorescent lamps, these tubes. So in a range of 50 to 100 to like a 40 to 65, 10 to 20, and like up to like a 0.3. So this is actually efficacy of these luminaires. So accordingly we can actually choose and place them. Further, like a typical outdoor light levels based on the like this source. So these are the actually sources of these light. For example, the ubiquitous, the direct sunlight, the sun, it gives like up to like a 1 lakh lux level. The light, a full daylight, we receive approx like a 10,000 lux, and like a overcast day, it has like around approx like 1000 lux at the time of dusk. It offers like 100 lux of like light level. At the twilight we get like a 10. At the deep twilight we get like a 1. In a full moon day we get lux level of 0.1. A quarter moon day we get like a 0.01. Moonless night 0.001. Overcast night we get only like 0.0001. So this is actually a relative a comparison of like a these outdoor light levels in a like a broad day, like a sunny actually daytime, and in an overcast night which is as like a is very dark. So you can understand and relate from here like how the lighting levels in the like external actually outdoor, it varies depending upon the hour and the seasonal actually effects. Further, in this slide, we are discussing over here mapping wind conditions for the wind power systems. So, like any place you may be aware of, depending upon the month of the year, there is always a this prevailing actually light conditions. So, in this one, this plotting, this wind actually rose diagram is actually plotted over here. So depending upon the month, these months have actually very little wind. These months have like an average. These months actually have the high winds over here. So this is plotted here on this actually rose actually diagram. Further, we have this hourly average speeds, at what hour of the day how much of wind is observed, and then daily average speeds. Then we have like a daily frequency distribution. So these actually charts are helpful in understanding what kind of like a wind patterns, what kind of wind movements are existing on any given actually site location, and accordingly we can go for designing our buildings. We can choose in this manner we can choose the location of the doors and windows and other openings, and we can strategize like depending upon the requirement. Do we want like a cross ventilation? We want like either we do not want like a cross ventilation and things like that. Further, this we have discussed before, but one more time, like how the topography helps in like creating like turbulences or the like wind actually patterns. So strategically you can see over here in this first sketch, like this is actually a good location for placing like a windmill, so that it receives the compressed flow of air, which is like a high in velocity compared to the other like regions, other these places in the foreground, and like such kind of actually places where there is a sudden rise in the like a topography, it creates like these turbulences, so this is actually not a preferable actually location for having houses, because there will be a turbulence in the like air most of the time of the day and the year. Similarly, these the urban obstacles also, such as like a large scale building structures or chimneys or these like warehouses, they also create actually this hindrance in the overall movement of the air, and they create actually in turn like a turbulences. So these also structures are necessary to be taken care of while we are designing for the wind movement in our like a premises. Further here in this slide, we have actually building shape considerations, like what kind of shapes will perform in like what kind of. So in this illustration we can understand more what are the actually boundary conditions acting on like any human body, including our own like regulatory mechanisms, bodily mechanisms, so which enables this like a human comfort actually situations which we actually desire for. So we have this sun as like a major source of like a radiation, and heat for us. So it emits like these short wave which are received by our like a body, at the same time we keep actually radiating some heat from our bodies, and then in turn like we have this respiration with the convection and evaporation at the same time. Evaporation is a phenomena like of like a sweating, you can understand easily. And then well, we have this protective actually layer of these clothing, and then we have like a convection, the air which passes through like touching our bodies, if it is like a cooler, it keeps on actually absorbing some heat from our body, or if it is hotter, it keeps on actually giving some heat back to our body, and when we touch any like a surface such as like a ground or furniture or anything, we keep actually conducting some heat to that body and resulting into some heat loss from that touch. So, or in an overall sense, you can understand this is how actually this the thermal energy is like a exchange keeps on actually happening on any like a human body. So the amount of energy what we receive, the amount of energy what we actually release through different means of convection and conduction, etc. So in and around this, in the next illustration, you will understand at the like this temperature scale of like a 35 37 degrees. So the our like a bodily like temperatures and the different like organs, they also vary. You may have like noticed our like fingers and other like ears and all. So they actually work as like a heat releasing units. You may have seen actually these like the hotter ears. So some actually physiological conditions, ear work as like a heat radiating unit, and they actually release heat in the like air through convection, trying to establish the equilibrium of the like a body temperature. So you can understand from here like these body conditions of like an unclothed like a mankind. So like the air, if air is at like a 30 degrees centigrade, the wall is as 30 degrees, and the air velocity at like a 0.05 meter per second speed, humidity at 40%, and whatever activity at like 87 like watts. So in this kind of situation, how body is going to like perform? So you see like in this quasi stationary state of like a neutrality, the inner heat production is equal to the outer heat loss from, you can see, these many sources. So the convection up to like 25%, respiration 10%, evaporation 20%, and radiation up to like a 45%. So this is the actually an exhaustive actually diagram and illustration of like how like our body's like a thermal neutrality, the tendency to create a like an equilibrium in the like a heat part, it actually works. Further different like activities, and they are like a metabolic like a equivalent MET. This is the term over here. You can understand when we are like a sitting like a performing an activity which is not very exhaustive, such as like reading. So this is like a taken as like a 1 MET. Then if you are playing an instrument, having actually some like a small like activity, if you are performing, this is like a 2 MET. Then if you are working on the computer, it has taken as like a 3 MET. If you are gardening or doing some like a normal activity, some like a little, not that heavy like a extensive activity, that is like a 4 MET. If you are biking, cycling, etc., that is 5 MET. If you are riding like staircase, you may have experienced when we actually keep on riding like these staircases for like a longer period of time, we feel like stressed. So this is like a 6 MET condition. If we are performing actually considerably good amount of like this physical activity like jumping rope, etc., or okay, so that qualifies for like a 7 MET. And if you are running around jumping heavily, that is under the range of like 80 to 10 MET. So this is the actually this activity and this metabolic equivalent scale, you can understand. So this is important to like to release the heat, and to actually consume the like energy, to spend the energy what we actually absorb from like a food and all that. So this helps in creating that actually established like an equilibrium actually metabolic activity in our body. Further, in this table, we have this equilibrium. So on the one hand, we have this heat produced in the body, and then on the other hand, we have heat lost by the body. So the activities you can see over here, you can understand like how our body actually establishes balance. And once that actually balance get disturbed, we experience actually some medical conditions such as like a fever. Fever is a one of the major actually symptomatic actually reflections of like a some disturbance going on under the like a body, inside the body. So the activities over here which produce heat inside our body are like a metabolism, convection, radiation, conduction, shivering, etc. They actually result into like a increase of the temperature inside our body. And evaporation, convection, radiation, conduction, etc., they all are also responsible for release of the heat from our body. And a normal actually human skin like a temperature ranges between like a 31 to like a 34 degrees centigrade. a maximum up to like a 43.4 degrees centigrade, as you can see from here. And average actually body temperature, the deep body temperature inside, which we measure through like a these thermometers, such as like when we insert in our mouth, or maybe when we insert deep inside our like these arms over here, inside the like these sides, so this actually readings give our like a inner body temperature. That is the standard is like a 37 degrees centigrade. So here we will talk about global comfort, like in with respect to like a human body. So the simplest statistical approach is to view the situation PMV is equal to 0 as the optimal case. Every deviation from this state means more or less like a some kind of like a discomfort. Another index by Fanger called PPD, for percentage of persons dissatisfied, can be used to analyze the average comfort level. It takes into account that a uniform comfort sensation for different people plainly does not exist, and postulates that even at PMV of 0, at least approx 5% of the people will be dissatisfied with this thermal climate. Another approach also available within Theseus FE is to establish the global comfort by using the mean skin temperature of the human. Two models are the TS thermal sensation and DTS dynamic thermal sensation indices. Some measured variables for judging the global comfort over here. For judging the local comfort, either the local skin temperature values or their time deviations can be used. Alternatively, the heat flow transmitted from the skin to the surrounding can be used. Within a simulation with Theseus FE, the heat flow between the virtual human and its surrounding is split into 4 parts. These are convective heat flow between the nearby air and the skin or the clothing respectively. Second, heat exchange resulting from short wave radiation, that is like a solar radiation. Thirdly, heat exchange resulting from long wave radiation, that is heat exchange between the virtual human and the car cabin. Lastly, heat flow within contact areas. These heat flows are highly dependent on the surface temperature of the virtual human body. For naked body, parts easy like hands, etc., this is equal to the skin temperature. For clothed body part, it is the temperature of the clothing itself that is to be used. So this is how actually this works, and from here on we will see some illustrations of like human comfort situations for like a thermal conditions are concerned, lighting levels are concerned, wind conditions are concerned, the acoustic conditions are concerned. So this is for our understanding. This is sourced from this actually website. You can go and refer. It has some more interesting actually insights, and illustrations to depict certain conditions. So from here you see this designing for the like a visual comfort. Well, this person is looking for some access to the views, and if related to him, if you see if this person has a exposure to the like outside and good views, so relatively who will be like a pacified and who will be contented is, I think, is very very evident. This person is getting like a lesser amount of light from the from this window. This person is getting an ample amount of light from the window for like reading and normal activities. Similarly here, this person has this lighting which is like giving a very lesser like a quantity, and the amount of water, the lux level is very little on the working actually top over here, and this has the ample actually lighting level. So these are the different actually conditions which depict certain conditions which we usually also encounter in our like daily life. When we feel that there is low light, then we feel intended to like switch on the luminaires, and increase the lighting actually level to meet the actually comfortable conditions. So this is actually a very generic psychological actually phenomena as far as this lighting levels are concerned. You can see in these more illustration, a person who is confined inside a space, a person who is sitting outside, and a space where there is some spaces actually these are lit, and some actually workstations are not properly lit, so creating an imbalance. So we must actually take care of like such workstations also, where this natural light cannot actually dig deeper, creating a balanced actually approach. And similarly, like what parts of the building, what components and surfaces of the building should have like how much of like a proportion as a, like a opening, that also should be like really thought of. That is the overall actually objective to understand from here. And in the lux level, you see like how this person has like a this light condition, and this has like a too much of light. So well, both are actually causing like a imbalance and a discomfort over here. So we must actually take a balanced approach in creating like a light. And then socio psychological conditions for like a visual comfort, so how like sometimes we want actually dim lighting, like for example for like a fine dining experiences and all, when we are sitting in a like an place, where we just want actually attention to like the person who is sitting around, so in this condition, well, this becomes like a desirable actually lighting level. So it depends on the actually uses also, and similarly you can see there are several of these illustrations, how they have actually impact on the overall like a comfort condition of like any human person. Further into this, like a sociological effect, psychological effect of like a thermal comfort, so a person who is feeling cold, a person who is feeling actually hot, the kind of differences they will feel. And yeah, similarly they will actually put on the clothing, and similarly actually they will go outdoor or maybe refrain from going outdoors, so such conditions are actually labeled over here. Some more like how the spaces, how the buildings can be actually designed to work around like a such actually actually the turbulent actually heating conditions. Sometimes they cause a discomfort by when the temperature actually drops significantly. Sometimes they feel discomfort when the temperature actually rises significantly. So how to actually establish a balance over here? So this you can understand, there are some illustrations which talk about in the same given like a room, one person actually feels cold, one person feels actually hot, so how this like varies from like a person to person also, how it is very very individual and personal. So how actually these things can be actually taken care of in like any given like a spaces design is the actually task for us to deal with the actually with deliberation. So maybe you can go through these illustrations in your leisure time. You can take it as a like a leisure activity for yourself, and you can go much in detail like how like a the future is going to look like, and how we can actually design the actually future of habitation, which we have discussed in one of our actually lectures. How this is going to be like in this illustrations you see here at the bottom. This house has its own actually controlled environment to grow even like a vegetables and things, and this is completely like a closed from outside to the like outside world. So how the future is going to be like, for the human actually the comfort conditions, that also we can understand from here. So this is designing for like a acoustic comfort. What are the actually sources of noise, and how those noise also sometimes become the musings, such as like a chirping of the birds, so we feel actually good when we hear actually these. But the moment there is like other kind of like a infrastructure or maybe heavy like activities, actually if they start producing like a noise, such as like factories and other like a mechanical units, or maybe heavy actually exhaust from like an aircraft, so we feel actually a terribly like a discomfort. So accordingly we can choose the material which help dealing with this acoustic actually condition. So some of these instances are beautifully illustrated over here. How the different activities inside like a building premises, sometimes they become musing, sometimes they become actually the causes of discomfort. So how these things can be actually taken care of in our design, that is actually a matter of like our deliberation. Okay, so this is you may be aware of this. This is psychrometric actually a chart. So this varies from place to place. Every place actually has their own like actually psychrometric chart, which actually depicts the comfort zone for like a humans. In the actually this plotted diagram of like the heat, the relative humidity, the wind conditions, the dry bulb temperature, etc. So this chart is a very crucial actually a piece of information for designing actually spaces, designing buildings. So we must actually consider this psychrometric chart. So this is actually a typical actually chart, where like this data is actually filled in over here. You can see these dots. So this is actually depiction of this dry bulk temperature. On this range we have this relative humidity over here. So this is like 100%, 80, 60, 40, 20, and things like that. So you see these boxes drawn in blue over here. So these are the actually two sets of like human comfort conditions for like winter months and for solar months. So we actually strive to bring the comfort conditions in this area in our like design spaces. So this is how actually we design for like a comfort conditions. So in this slide you can see this is the like a status point plotted on psychrometric chart. So here it shows like what kind of actually conditions are required if we are moving from this actually standard balanced place to the like these many like directions. So if you are moving up, that means like a humidifying is actually an important actually factor. In this way actually heating and humidifying, in this way heating is needed. In this side actually cooling is needed, and this side cooling and humidification is needed. This side like a cooling and dehumidification is needed. Similarly you can understand from here like once the actually temperature of any given place, the relative humidity, the wind direction, the wind movement, etc., once they actually keep on changing and fluctuating, then what kind of induced actually phenomena will take place are shown through this table over here. Further, this is a actually graph identifying periods of comfort and periods for which shading is required for the city of like a New Delhi. So you can see this temperature ranges are drawn on this axis. Okay, dry bulb temperature from 0 to like a 50, and on this scale we have the number of like months, total 12 months, January to December. And yeah, this side we have this solar radiation from 0 to like a 2500. So you can see from there how this temperature actually keeps on actually increasing in these many months. So this is shown through these actually dotted lines. Like in this zone heating is needed. You can see over here this actually orange actually a dotted line, and this is actually this green dotted line is a period of like a comfort. So the natural actually elements are at such a balance that the overall like in an overall sense, the outside the temperature and the combination of humidity and wind speed is at the comfort level. And in this blue period this cooling is required. So this is how it is mentioned over here, at which time of the like which month of the year, what kind of actually conditions are prevalent and what is needed to be done. So this is how actually depicted over here. And in this actually with this dark blue actually dotted line, it is shown like the shading is needed. So shading almost you can see once the temperature actually rises above like 16 degrees centigrade on like a dry bulb temperature, it is expected that some kind of like a shading is necessary in this actually city of like a New Delhi. Further we have this comfort zone. So accordingly actually we can rework our like designs, how we can based on these previous like 2-3 slides, further we can plot actually a region, a zone, where comfort conditions can be actually created inside any given like a building premise. So this is the actually solar path diagram. So the shading analysis, and the decision of the like a final form of the buildings can be actually taken care of through this analysis. So this is a shot from like this solar path diagram, which shows actually the location and the intensity of sun at like a different time and different months of the year. So you can see the temperature ranges from like a 33 degrees to like a 40 degrees in centigrade over here are depicted with these like a 5 different colors of the sun, and its location. So similarly like in these winter months, you can see over here the temperature is below like 33 degrees. So this sun can easily penetrate deeper inside the spaces, and here when the sun is actually shown in the like red dots, so the temperature is above like 40 degrees. So how the shading will be required and all that. So this kind of like analysis can be done actually through this site. So with this actually we have come to the end of this lecture. Thank you everyone.